Let's talk about tools, or burrs, as they're often referred to in dentistry. As an open solution, the DWX series of dry mills can use tools from a number of manufacturers, and they can be designed for specialist materials and applications. All the tools here have a 2mm cutting diameter and a 4mm diameter shank. If you look closely, some are rounded at the tip and others are flat. Your CAM software will select the right tip shape relating to each milling process. As an example, for anatomic elements of a tooth, you want a rounded tip or ball nose tool. And when you want to create a mechanical interface, a flat tool is chosen. But tip shape is not the only difference. Look at the neck or the reach of each tool. Longer reach tools are good for thicker restorations, allowing the tool to reach deeper into cavities or to give a clearance for undercuts when the 5-axis simultaneous movement angles the material. Longer reach tools do not have the same stability or strength as shorter tools. This is why tools for harder materials and tools which have a smaller diameter tend to have a shorter reach. Some tools are also coated, and this is a hardened coating for specific materials. And for those with eyes younger than mine, you'll also notice varying cutting or flute lengths, and also the difference in the geometry of the helix. A lot of development goes into tool design, so choosing the right tools is really important. One critical aspect of tool selection is the integration in your CAM software. The software needs to know every aspect of the tool geometry for collision avoidance, and also how fast and how deep that tool can go into each material. At DD Shape, we work closely with CAM software providers to ensure our DWX users are getting the best performance in terms of tool life, production cost, and of course, milling quality. The CAM software also needs to know where to pick up the required tool, meaning the location or slot in the ATC magazine, the Automatic Tool Changer magazine. If you are using our master kit, the included card lists the location for each tool to match the CAM software settings, and also gives you a short description of applications and suited materials, along with the expected lifespan. So let's prepare a tool. For this you will need a torque screwdriver with the 0.3 Newton meter torque sleeve fitted with the 1.5mm hexagonal tip. You'll also need a milling burr holder, mounting screw, the milling burr positioner, and last but not least, a tool. You'll notice the milling burr holder has a plastic insert on the upper side. This is green for the 52D Plus model and the 53DC. For older models, it is white. The plastic insert acts as a shock absorber for the collet as the spindle descends to collect the tool, so it is essential that this is fixed facing upwards. If the fixing screw is not already fitted, partially tighten it, but not fully. Now place the burr holder into the recess of the positioner, plastic insert facing upwards. Slide the tool into the burr holder, ensuring that the tip of the tool is within the window. Now tighten the screw. Looking at your cam or reference card, place the tool in the correct ATC magazine slot, taking care to avoid damaging it and ensuring it is fully seated and flat in the magazine. Repeat this process for all your required tools and you're ready to go.